Good morning, good afternoon, good evening, wherever you are in the world. Hello, I'm Dr. Jeff Rosashan, Director of the Crops of the Future Collaborative at the Foundation for Food and Agriculture Research, or FAR, as we like to be called. Welcome to today's webinar on fast-tracking climate solutions from Genebank collections. Before we begin, please keep in mind that this webinar is being recorded and all participants are currently muted. We will open lines for Q&A, and if you have a question, please use the Q&A or the chat function. We'll be monitoring that throughout the webinar so we can call on particular questions. If you aren't familiar with FAR, we build public-private partnerships to fund audacious, use-inspired food and agriculture research. I'd like to begin by providing a bit of context for our discussion today. As we are all aware, global food systems are being dangerously impacted by climate change. Droughts, extreme heat, and flooding decrease agricultural production and reduce harvests. Individual farms, including smallholder farms, comprise the majority of the world's farmers. Losses on these farms from climate change have a ripple effect on the global food supply, increasing food costs and worsening food insecurity and malnutrition. These impacts are particularly felt by those in the developing countries of the world. The Fast Tracking Climate Solutions from CGIAR Genebank Collection Program aims to address these challenges by equipping farmers with crops that can withstand environmental extremes. The program is expanding existing crop improvement research to develop new crop varieties adapted to the stresses of climate change. CGIAR, the world's largest public sector agricultural research partnership, holds around 10% of the worldwide germplasm, meaning seeds and other genetic material in gene banks across the globe. This ambitious research program, led by CGIAR, is developing approaches and tools that harness the gene bank's genetic diversity to develop climate-resistant crop varieties for millions of smallholder farmers worldwide. This research program also has potential to benefit farmers and consumers in developed countries. COP is an important opportunity to secure the funding needed to reduce emissions and adapt to climate change on a global scale. Our organizations have partnered to tackle global food and nutritional security in the face of climate change. This collaborative research is leveraging FAR funds provided by the US government to accelerate research that can ensure yields of critical, stable crops. This program is an impressive example of leveraging investment as well as research. We are proud to showcase this research at COP as one of the Aim for Climate's original innovation sprints. To tell you more, I'm joined today by key stakeholders, including Dr. Eliane Ubalejoro, a member of the Global Crop Diversity Trust Executive Board, as well as the Executive Director of Sustainability in the Digital Age and the Global Hub Director in Canada for Future Earth. She is also a professor of practice for public-private sector partnerships at McGill University's Institute of the Study of International Development. Dr. Sarah Hearn is a principal scientist at CIMMYT CGIAR, where she focuses on identifying and upcycling breeder-relevant native genetic variation for broader crop improvement applications. Dr. Bram Geurts is Director General, also Secretary General and Chief Executive Officer of CIMMYT CGIAR. He brings together multidisciplinary science and development teams to integrate sustainable, multi-stakeholder and sector strategies that generate innovation and change the agri-food systems. Dr. Gary Atlin is a Senior Program Officer of the Research and Development Team of Agricultural Development Initiative at the Bill and Melinda Gates Foundation, where he manages maize, wheat, and rice breeding investments that aim to increase the productivity, incomes, and resilience of small-scale farmers in sub-Saharan Africa and South Asia. I'm delighted to welcome you all and that you could join us, and I will now turn it over to Dr. Ubalejoro.
Thank you very much, Jeff. So it's a real pleasure to be here. And projects such as the Fast Tracking Climate Solutions from CGIAR Genebank collections are really critical to building a more resilient food system and could not be more timely given the growing threats of climate change, pest and disease outbreak, conflict, and more. The crop diversity found in Genebanks are the building blocks of sustainable agriculture and a crucial component of ensuring that we can adapt agriculture to the climate crisis and reduce environmental degradation while improving livelihoods and feeding everyone adequately. The Crop Trust is very supportive of this initiative and similar projects to characterize the diversity held in international collections. By understanding the diversity in collections better, the material conserved in gene banks can be more effectively and efficiently used in breeding and research to adapt agriculture to future challenges. It must be noted that without the conservation of crop diversity in gene banks, initiatives such as this one would not be possible. We are losing the diversity of crops and their wild relatives at an alarming rate. This erosion of crop diversity is undermining the resilience of food systems. Securing the world's crop diversity and making it easily accessible for use can be done safely and cost-effectively in gene banks. Only by safeguarding this diversity in gene banks and making it available for use can researchers and plant breeders adapt agriculture to climate change in a sustainable and environmentally friendly way. We see crop diversity as a global public good. Multilateral instruments such as the Plant Treaty are essential to ensuring this diversity is available to all and of benefit to all. Without the Plant Treaty and the multilateral system of plant genetic resources for food and agriculture, initiatives such as this one would not be possible. The treaty guarantees that the diversity conserved in gene banks is accessible and can be used by researchers and plant breeders according to agreed rules. We cannot begin to adapt our food systems to climate change without investing in the conservation and use of crop diversity. Crop diversity is essential for life on Earth and requires buy-in from all. As an essential component of the funding strategy of the Plant Treaty, the Crop Trust recognizes the importance of multilateral cooperation. Studies show that as climate change grows more severe, the interdependence of nations on plant genetic resources for food and agriculture will increase. In 2021, a total of 96,590 crop diversity samples were distributed by CGIAR gene banks to users. This number is only expected to increase as climate change creates the need to adapt new varieties and perhaps even new crops in particularly stressed areas. We have a window of opportunity to protect and make available the foundations of the world's agriculture, but it's closing and we must act now. Biodiversity is disappearing in fields and in nature. Initiatives such as this are an important step in creating a more resilient, nutritious, and accessible food system for all. But they cannot do much if the diversity isn't there in the first place. More can and must be done to ensure that crop diversity is conserved. The loss of a crop variety is irreversible, and the Crop Trust is working to ensure this precious global common good is conserved and made available to everyone forever. The Crop Trust is hopeful that projects such as Fast Tracking Climate Solutions from CGIAR Genebank collections and the Crop Wild Relatives project will continue to discover traits that can be utilized to develop new varieties of crops able to withstand the effects of climate change. So I'm just going to share some examples that I think are really relevant to this type of work. In terms of the crop wild relatives, so they're cousins of our food crops that still grow in nature. Many have evolved to survive harsh conditions such as dryness, wetness, high temperatures, and poor soils. This means they can be a source of new genetic diversity that plant breeders can tap into to develop more resilient food crops. But crop wild relatives are under threat. If they disappear from the wild, the valuable genes they contain will be lost forever. So the Crop Wild Relative Project, funded by the Norwegian government and implemented by the Crop Trust, addressed this through a 10-year global project that's ongoing, was ongoing from 2011 to 2021. And aspects which continue are also being pursued with the Crop Trust's BOLD project that is ongoing from 2021 to 2031. So as an example, the new Jabal variety was developed by crossing cultivated durum wheat with one of its wild relatives collected in Syria and has recently been officially released in Morocco. Jabal, which means mountain in Arabic, was requested by farmers through consultations with crop breeders because it adapted so well to drought. Durum wheat is produced primarily for making pasta, but is also an important ingredient for couscous and bulgur, which are particularly popular in North Africa and the Middle East. these regions which are becoming hotter and drier and where reducing yields are being seen. So this drought-tolerant durum wheat variety was developed under the Crop Trust Crop Wild Relatives project and is one of the crops that will continue to receive support from the follow-up BOLD project, which is an acronym for Biodiversity for Opportunities, Livelihoods, and Development. So the Crop Trust partners are using diversity in gene banks to develop resilient varieties of barley, durum wheat, grass pea, alfalfa, finger millet, rice, and potato that can withstand the effects of climate change. We know that in the early 70s, outbreaks of a disease called grassy stunt virus, GSV, destroyed more than 116,000 hectares of rice fields in Asia. Grassy stunt virus, which is transmitted by the brown plant hopper, causes rice plants to produce deformed grains or no grains at all. Epidemics of grassy stunt virus can lead to substantial reductions in yield or even cause total loss of a harvest. The Economist estimated that the grassy stunt virus caused damages of over $300 million, worth more than over $1 billion in today's dollars. So when scientists at the International Rice Research Institute screened 6,723 different types of cultivated and wild rice for resistance to the virus, only one was found not to be affected. So this particular accession is a sample of the wild species Oryza nivara. Breeding using this particular wild population eventually led to development of improved rice varieties with resistance to GSV. These were released in many countries in Asia, helping thousands of farmers combat the disease and avoid big losses in rice production ever since. Another example is that's really important in terms of safeguarding wild relatives of crop rice is a species that in rice that today enables productive rice varieties to survive up to 2 weeks underwater. This is FR13A. It was originally collected in India in the 1950s. At the time, nobody could have guessed how important it would become in the face of extreme floods and climate change. So FR13A's superpower depends on a gene called SUB1, which, when bred into modern rice varieties, enabled them to bounce back, quite literally, after being submerged and thrive until this was time for them to be harvested. So at a time where we know that there are more and more issues related to flooding around the world, there's an urgency to really identify these precious genes and these wild relatives. So just to conclude, another really important crop for humanity today is potatoes. And one of the biggest challenges that potato farmers face is late blight. Every year, it costs potato farmers about $10 billion in crop losses. That's the same devastating fungus that caused the Irish famine in the 19th century. And due to the warming climate, late blight is destroying crops in areas where it had never previously been seen before. Working together with farmers in Peru, the International Potato Center, with the Crop Trust support, successfully combined the disease-resistant traits of potato wild relatives with the tasty, high-yielding qualities in domesticated potatoes. The result was a new variety called Sipmatil, which has just been released to farmers in Peru. So just to say, I'm really honored to be here today with FAR because this is a really critical initiative for the world, and I look forward to seeing this grow and scale and have more effect to help farmers and sustainable diets everywhere in the world. Thank you.
Thank you very much, Eliane. Some great examples of the importance of crop diversity and how we can really use it, particularly in the face of climate change. Next, we'll hear from Dr. Sahara Hearn.
Thank you very much. And good day, everybody, from what you can see is a very bright and sunny Mexico. So as outlined, crop genetic diversity is a fundamental building block of crop improvement globally. And the genetic variation for tolerance to climate change features faced by farmers, such as drought, high temperatures, or flooding, has never been more important and more relevant. So using such variation in crop improvement helps enhance a crop's inbuilt potential to adapt to climate change. It provides farmers with seeds or clones that have a form of genetic insurance against the ravages of climate variation. The CGIAR network of international germplasm banks holds in trust for humanity under the International Treaty on Plant Genetic Resources for Food and Agriculture a vast collection of native diversity of crops of fundamental importance to food and feed globally. The 11 gene banks of the CGIAR comprise the largest and most frequently accessed network of gene banks globally, with the CGIAR distributing 94% of all of the materials shared under the international treaty annually. Now, while we say all the diversity is wonderful and we have some beautiful images of different crop diversity on the screen, not all diversity is beneficial for farmers. There are a number of characteristics which breeders over the decades have selected against, things like disease susceptibility, very tall plants that fall over in the field. And the alleles and genetic variation for these kinds of characteristics are present in a much higher frequency in gene bank accessions than they are in the breeding materials used commonly today in variety development. Breeding has essentially tamed some of this diversity. Breeders have selected against features that are considered negative or deleterious and selected for features that are valuable. But in the process of this selection, crossing, and screening that is used by breeders, some variation has been inadvertently left behind. Valuable genetic variation is essentially still sat on the vaults of the germplasm banks. Now, these CGIAR collections are full of containers of seed and flasks of little plantlets. And despite the obvious diversity we can see in things like seed color and size, it is impossible to visually identify which of these vast collections, which entries carry novel variation for features like drought tolerance. So for a breeder, trying to identify this new genetic variation to develop more climate resilient crops is a little bit like going into this supermarket that we see here to buy an ingredient to make a meal. All of the products on the shelves are pretty much unlabeled. You don't know which one to select to make the product that you need. This innovation sprint focuses on the exploration of discrete gene bank collections, and to date, this effort encompasses 6 important species spanning cereals, legumes, and clonal crops, and there is room to add more to broaden that scope. Through strong partnerships, multidisciplinary activities, we're bringing together the power of genomics, GIS applications, targeted phenotyping, quantitative and population genetics, statistics, and applied breeding, all together to characterize and explore these collections, identifying novel genetic variation of value and potential for climate change adaptation. And we are repackaging that, retaming that, to develop products that breeders can then use in their crop improvement programs, to develop the new hybrid, open pollinated, and landrace-based varieties that farmers demand. This is rather like adding labels to the cans on the supermarket shelf. For the future of breeding, we aim to provide scientists with the knowledge to make informed selections from the germplasm vaults, identifying from this vast diversity supermarket the products best suited to meet the needs of the farming communities that these products are being developed for. Now, this effort is only possible because of the work that's gone before. Dr. Gewurz will speak to this, I'm sure. This effort is only possible because these collections exist and they have been conserved for humanity, as Dr. Ubali-Joro described. It is only possible because we work across disciplines, across geographies, and across a science and research community which sees value in sharing the relevant data and germplasm resources as international public goods aligned with global treaties and conventions. This work is only possible because of the sponsorship from funders like BMGF and FAR. And finally, only possible because farmers have over millennia themselves selected and informally bred these crops to develop the rich heritage of diversity we see today in the gene banks and farming communities of the world. And with that, back to you, Jeff. Thank you.
Thank you, Sarah, for really laying out what this project is all about and how it's really being built on a lot of work that happened before and that we're able to utilize to really help come up with some positive opportunities to help people deal with climate change, particularly for our food systems. Thank you. Bram, I'll now turn it over to you.
Thank you. And first and foremost, allow me to thank everybody online that is joining us. But I also want to thank FAR and the Bill and Melinda Gates Foundation for being such strong partners as institutional partners in this endeavor. But of course, Jeff, Gary, thanks for your personal leadership. This seminar would not be possible, but the project would also not be possible without you. Of course, the Crop Trust is a crop trust together with other international research organizations. The National Agricultural Research System in each of the countries are valuable partners. And without your trust day to day, we wouldn't be able to generate this impact, even to pull this all together. So thanks for the trust you give us daily. As Dr. Sarah Hearn was mentioning, this is the first sprint announced actually in the COP26 as a part of the aim for climate innovation sprints. This initiative financed by FAR and BMGF aggregates projects of non-governmental and publicly funded organizations like ourselves and the rich partner networks, and therefore targets to elucidation of innovations that can address the challenges that climate change brings to agriculture now, but also in the future. This sprint is for me a clear example of the shift in paradigms that we are looking for. One of the big questions to answer today is, what do we need to do so that people in 2100 actually can say, luckily in 2022, they took the right decisions and we're living in a better world. The second shift is that we need to shift from resolving yesterday's problems tomorrow by resolving tomorrow's problems today. I think this project is an example where we not only try to future-proof the seeds that 10 to 15 years from now will be in farmers' fields, but especially to start from the demand and needs driven out there by farmers and their families. Therefore, the collaboration with the National Agricultural Research System, that is the reflection of what society requires, is so essential to what we're doing in this effort. The innovations are like the new sources of genetic variation, however, are only one tool in the toolbox, a very important tool, a tool that starts from this precious network of gene banks that we have where the biodiversity is safeguarded. But it needs to be accompanied by the appropriate translation into impact that can only happen if we also combine environmentally, culturally, and system sustainable ways so that this innovation cannot be just a magic bullet, but integrated in the systems we try to transform. The seeds of today that we're generating from this innovation with the right genetic variation needs to get to the farmers in a future-proof way. And therefore, we also need to accelerate the access so we cannot get them in their hands 15 years from now, but 10 years, 5 years from now. And that will require enabling support by agricultural extension systems that give access to microfinance and enables agricultural food policies, innovations across a systemic approach in the and of course in the food, energy, and water nexus. Because it's only like that we can completely respond to the need for nutritious, affordable food and feed that can respond to local, regional, and global needs and is made available at those scales. This project is at the heart of achieving that effort. The challenge is big because we're working with complex system problems. Therefore, it's not going to be one entity who can deliver these innovations for impact. We're going to need to work together. This 30 million partnership, therefore, is an example of how we can come together with public, private, and social efforts to develop a sprint that builds on a strong foundation of over 10 years of support to CIMMYT, for example, by the Mexican government under the Masagro Crops for Mexico effort. It actually was the president of the Bill and Melinda Gates Foundation himself, Bill Gates, who challenged us to grow the program, but also challenged us to go the next step. It took us 10 years to put this together. It took us 10 years to actually make those first research steps that could be integrated. That was only possible through the additional support of the CGIAR research programs, famous CRPs, the UK Biotechnology and Biological Sciences Research Council, or BBSRC, and the work from many, many scientists in CIMMYT, in the CGIAR, in the Genebank network, in the local universities, in the national research actors we work with. Diversity in sponsorship is like diversity in biodiversity. If we bring it together in the right way, we can create even bigger and diverse partnerships, and therefore can attend these wicked problems that we're looking at today. They're multifaceted, and they will require multifaceted solutions harnessed from skills many disciplinary and multidisciplinary teams. We are ready to work extensively with all those bright minds out there in the countries, working day to day in the system with small and medium enterprises, with NGOs in different geographies, in different agricultural environments. Together, we can co-develop, co-test, and co-combine our knowledge towards a diverse range of innovations that can actually inject in farming systems that are tailored to the context. And yes, of course, we also need gender and an inclusion lens in order to make that happen. The work of this sprint is therefore an example that fits into that of a whole range of endeavors undertaken by scientists like breeders, seed system specialists, agronomists, anthropologists, extension agents, spanning multi-institutional networks, together working to translate the promise of genetic insurance, the potential of our genetic diversity into real climate resilience, into real sustainable food production in farmers' fields. It is very dangerous to say that we are at the pivotal moment, but I'm still going to say it. We're at the pivotal moment. We're in the middle of the 4 Cs. The outcome of the COVID crisis, climate change impact, a crisis or a conflict, and of course, the cost of living that is increasing. If we want to respond to this pivotal moment, we're going to require partnerships. We also have to be aware that this is a pivotal moment, but it's also the first moment in the history of humankind where we have access to this amount of data. We have access to these computational and understandable practices so that we can transform that data into the capacity of decision-making, decision-taking, and decision support that can generate the innovations we need. In order to get there, we will have to listen to what is required. We will have to leap forward and come out of our comfort zone. And we will have to learn by doing. And yes, that also means we will make a mistake every once in a while. But more important, let's simply get to work. Thanks a lot.
Great. Thank you, Bram, for your remarks, for reminding us that food is not just global, but also local. And I think also emphasizing the importance and the role of COP and the whole global community in trying to address climate change, and also reminding us that maybe time is not our ally. And so we really need to get moving. So thank you very much. And now we'll hand it over to Gary.
Thanks very much, Jeff. I'm very grateful to FAR for having organized this panel and inviting us. The Bill and Melinda Gates Foundation is very pleased to be supporting CGIAR centers like CIMMYT and its sister centers and national scientists in increasing their capacities to support climate change adaptation in the farming systems the developing world depends on. I'm going to build on an example that was referenced by Dr. Ubali-Joro. And we can see the outcome of work on rice flooding tolerance that she referenced in this slide. It's an relatively early success in the area of benefiting from Genebank resources. Dr. Ubali-Jora referred to a gene bank accession FR13A, a traditional variety that has the ability to withstand total submergence. There is a long research effort and development effort clarified that this capacity is provided by primarily by a single gene, sub1, naturally occurring gene in that gene bank variety, FR13A, that greatly improves the ability of rice plants to withstand total submergence. Normally, rice plants are killed by about 3 to 5, maybe 7 days of total submergence. And flash floods with that level of submergence occur every year in thousands of hectares of rice fields around South Asia, Southeast Asia, Sub-Saharan Africa. Incorporation by conventional breeding methods, marker-assisted selection of the sub1 gene, which originated in a gene bank accession, can increase the ability of rice to survive submergence by up to another week, up to about 2 weeks of total submergence. The Gates Foundation started supporting rice breeding work to allow farmers to benefit from this variation in 2006, and was very excited by the potential of sub1 and other alleles conserved in gene banks, most as yet undiscovered, to increase the resilience and stability of crop production in the face of a rapidly changing climate. It's important to recognize, though, how much work was required to move us to the example that we see here. And just to explain that, on the right-hand side of that photo, this is a photo that was taken in a farmer's field in Uttar Pradesh in India about 8 or 9 years ago. As a result of an intensive research effort, the sub1 gene from FR13A was back-crossed into a widely grown commercial variety, Swarna, which is grown still on millions of hectares in India, Nepal, and Bangladesh. But in rain-fed areas that are quite subject to flash flooding events, and Swarna is not resistant to submergence at all. So when it's submerged for more than a week in a flash flooding event, you'll see damage of the type you can see on the left-hand side of the slide. A version of Swarna that was into which has been incorporated by conventional breeding methods, the sub1 gene from FR13A, is seen on the right, and it survived that flooding event quite nicely. The problem or the difficulty in helping farmers to benefit from this type of variation is that it's often locked in very low yielding varieties, the traditional varieties in the collection. The original variety FR13A is not directly useful in modern crop production because it's tall, falls over easily, and is low yielding. It's also susceptible to a number of diseases. It's even difficult to use directly in breeding. The benefits were unlocked as a result of an intense collaboration among scientists at the International Rice Research Institute, universities, and the Indian Council on Agricultural Research over about 20 years. That resulted in the localization of the submergence tolerance gene and its incorporation by conventional approaches into a number of widely grown Indian rice varieties. This process of unlocking these benefits and making them available to farmers in the global South was quite slow, both due to the technology and breeding approaches that were available in the 1980s through the 2000s, and because the interinstitutional partnerships needed to quickly identify, characterize, and make available climate adaptive variants from the gene banks had not been implemented. And this rather slow process also characterizes other examples of gene bank contributions, which include disease resistances of the type that were referenced by Dr. Ubali-Joro, like wheat rusts, fungal diseases that appear to be increasing in both frequency and severity as a result of changes in rainfall patterns. These resistance genes are from being accessed from the collections of CIMMYT, Dr. Govert's institution, and the International Center for Agricultural Research in dry areas, ICARDA, have been successfully deployed to fight these resurgent diseases. But we really need to accelerate the process to reduce the time taken from about 20 years in many of the current examples to perhaps 5 or 6 years. Successes like the access to the benefits conferred by Sub-1 convinced the Gates Foundation that there's great potential to accelerate climate change adaptation in the farming systems that feed the global South. By supporting the discovery and application of gene bank variation, conferring resistance to climate stresses, not only including flooding, but also increasingly drought and heat, and to the pests and diseases whose destructiveness is increasing with increased temperatures and more variable rainfall in many regions. The project led by Dr. Hearn, which she was describing, is an innovative pilot in this area. It aims to use up-to-date tools and effective partnerships to rapidly detect useful genes in the collections and make their benefits available to farmers in the development much more quickly. Even after the worth of a resistance gene is validated, it's detected in the gene banks. A great deal of work is needed to make it usable by breeders in national agricultural research systems in creating more resilient varieties for the farmers they serve. And a unique feature of this innovation sprint is that it will not only identify climate adaptive variants in the collections, it will make them available quickly in useful forms to plant breeders in the national systems. The project is a unique and systematic collaboration between advanced university programs, CGIAR gene banks, and national breeding networks serving small-scale producers in Africa and South Asia. Without careful coordination between gene banks, agronomists, and breeders who understand the climate changes faced by farmers, and the geneticists and crop physiologists who characterize and localize useful genes, benefits to farmers will be delivered very slowly. The Gates Foundation is very optimistic that this interdisciplinary, interinstitutional, and farmer-focused approach being piloted in this project will greatly reduce the time needed for benefits to be delivered in farmers' fields. And previous speakers have indicated the tremendous urgency of this task. We can't accept a 20-year lag for these benefits to be available to farmers. We need to cut that to 5 or 6 years, and this project will serve as a model for how this can be done. As Dr. Govert noted, gene bank resources and improved varieties are not the only tools needed to help farmers cope with climate change. Farmers also need to maintain the fertility of their soils via access to affordable inputs and sustainable crop management practices. They also need to be able to finance the purchase of those inputs, ensure their livelihoods against catastrophic climate-related losses, and get their crops to market to generate income. This support is especially needed by women farmers who usually have much poorer access to climate-adaptive information and inputs. But the climate resilience of crop varieties supported by this project is a key building block of adaptation. The Gates Foundation believes that greater support for plant breeding, the mobilization of the diversity in gene banks, and agricultural research generally is critically needed if we're to meet the very urgent challenge of adaptation. Thank you very much.
Great. Thank you very much, Gary, for that presentation. For especially, I have to say thank you for all of the really tremendous work that the Bill and Melinda Gates Foundation does, particularly with respect to really working to help build food security. But I think some of the other issues that you mentioned as well, that I know that the Bill and Melinda Gates Foundation is also directly involved in, particularly looking at financing, looking at gender equity, looking at a lot of the problems that need to be solved on a global scale in order to meet the challenges of climate change. And so, again, I would like to thank all the panelists very quickly and open it up for questions. I think there were a couple in the Q&A, so maybe I'll look at those and see if there's anyone in particular that wants to address them. So we got a question from Raja Ragaputhi, who I believe is with Agriculture Agri-Food Canada. The question is, perennial rice is released in China. Any plan to develop perennial wheat along with Land Institute by forming a global consortia led by the Crop Trust, CGIAR, CIMMYT? And he points out that these perennial type crops capture carbon with their root system. Is there anyone from the panel that would like to try that one? Oh, Sarah, you've got your hand up.
Yeah, perennial crops are very interesting. And as outlined, they have a potential role as a carbon sink. I think the key thing to consider here is what is really demanded by farmers themselves. To date, there hasn't been a huge push for perennial wheat, but it is something that a lot of the socioeconomic groups across the CG, not just at CIMMYT, are starting to look at in collaboration with partners in the national systems to see whether that may be a particular technology, if we want to think of it that way, that farmers would be keen to adopt moving forwards, considering some of the other challenges that can come from perennial crops, such as unintended weediness and things like that.
Great. Thank you, sir. Gary, you've got your hand up as well. I'll go to you next.
Just a quick addition to that, the ability to deploy something like perennial wheat really depends on the cropping system. So, for example, on the Indo-Gangetic Plain, millions and millions of hectares of wheat are grown, but they're grown in rotation with rice. So the rice is grown in the wet season, wheat is grown in the dry season. So in situations like that, if farmers are going to plant a perennial crop, they're going to need to stop growing the other crop that they grow in rotation. So the ability to use that type of innovation will be pretty context specific.
Thank you, Gary. I will just briefly comment that through some of FAR's research programs, we have funded a few programs that deal with the development of, well, I'll call it perennial wheatgrass, which is my example of that. But as we talked about, the breeding required to bring some of these crops into a competitive position where they're yielding as a food crop or a feed crop compared to some of these other crops is going to take quite a bit of time. And I think, given the comments that the other people on the panel made, also a lot of work still needs to be done as far as fitting them into existing crop rotations. But I do say to Raja's question, there needs to be more research, investment in these crops, because they do have some particularly environmental benefits that may help in the face of climate change. Got another question here from Fontegro. It's from Eugenia Saini, and it says, thank you very much for this meeting. At Fontegro, we're building a new initiative on local gene banks. And I'm not sure Eugenia, what ALC stands for, through the national research organizations and indigenous communities. We would like to explore with you a joint initiative and bring the opportunity to create a more broad impact on local communities, strengthening food security. Is there anyone that would like to address that one? Eliane?
I just want to say that, I think some of my colleagues were talking about the importance of strengthening and supporting national agricultural systems. And I think, Eugenia's question is really about how do we partner locally and in context to do things better. And I think all of us are really interested in being of service to the smallholder farmers around the world that, feed 75% of the planet. And so how we do that is critical to listening to smallholder farmers, to indigenous communities, because of the tacit knowledge that is held and the traditional knowledge systems that they have access to. And these are critical to moving forward in conjunction with the data-driven, acceleration and all of the amazing tools we have today in genetics. And so I see both as critical to how we move forward.
Right.
Just to complement, I think in that sense, the Fantagro platform is a great entry point, but also I would go a step further. I think some of the experiences in collaborative projects that Fantagro has done can be extracted as learnings that can help us design the concept and methodologies of better doing those stacked partnerships that go from the local to the regional to the global. So for sure, interested in that conversation with Fantagro.
Great, thank you, Bram. Any other comments from the panel? Okay, seeing none. So one of the questions that I would like to pose to the panel is, what results do each of your organizations hope to see emerge from the Genebank Collections Initiative? Anyone that would like to start that one? Oh, Eliane, very good.
I mean, for the crop trust is how do we ensure that crop diversity and diversity in wild relatives is preserved forever? And so, for us, it's really how do we ensure that this global public good is enriched and that we don't lose any biodiversity given the accelerated losses that are currently happening and how climate change is affecting some of the centers of biodiversity in this world. And so we see this as just really critical work for the future generations, and how do we just grow it and accelerate is our interest, and we're just thankful for these types of projects to exist.
Anyone else like to comment? Gary?
Yeah, the foundation, of course, is extremely concerned about the security and the sustainability of the collections. As far as this project is concerned, this innovation sprint is concerned, we are really looking for a step change in the speed and effectiveness with which the benefits that can be accessed from these critical collections can be made available to farmers. So we're very much hoping that the project will generate a pathway to faster realization of those benefits because of the urgency of the problems that we're addressing, resulting from much faster and sharper climate impacts than perhaps many of us expected a few years ago.
Maybe Bram, would you comment, since the CGIARs actually hold a good portion of the Genebank collections?
And in that sense, I would summarize it in 3 points. I think point number 1 is that we're really working against time, and we need to adapt those crops and farming systems so that they are future-proof. So I think what we want to prove here, or what we want to show, is that as a network of gene banks, that we actually can unlock the potential by starting from the future and the future reality, and backcast that in what today are, call it, no regret investments or no regret traits that need to be in that biodiversity and that availability of seeds for farmers. So that's number one. Number two, specifically, I think we are here at an endeavor where we can extract because we're looking at multiple crops, including the smaller crops, including the orphan crops. I mean, we're really looking at the whole spectrum, and that will allow us to extract methods and concepts that are really, I wouldn't say universally applicable, but at least that are stress tested in that multi-crop environment. And I think that will shape also new thinking of the scientists and the scientists community to really think from the crop, from the local to, let's say, the group of crops, and let's say to then that global level, or in this case, that multi-crop level where you can extract knowledge at a strategic, methodological, and conceptual level. That would be my second. And my third, for sure, I think that this project allows us, or especially this sprint, allows us to test how can we do partnerships better, more effective, for those kind of wicked system problems. And that per se is actually a gigantic experiment, how to work together and consider it an institutional experiment, a partnership experiment of that this project allows per se.
Sarah, anything to add to that, or?
No, it's all very nicely covered. I mean, there was another question I did spot, and Bram mentioned orphan crops, so I'll start to tackle that one a little bit as well. I mean, the opportunities here are vast. Yeah, we're currently working with partners on 6 species, and initially we've tackled some of the larger commodities simply because of the potential scale of the impact of any innovations that are developed. But a lot of the tools, the techniques, the know-how of what to do, and more importantly, in many cases, what not to do, are invaluable for all of the commodities that we're looking at. And certainly for the orphan crops and the less studied crops, they tend in breeding history to be much closer to the germplasm banks right now. They haven't had the long period of extraction and time away from those initial landrace accessions. So I think the opportunity there is potentially even greater to really start to look at the existing resources and see what genes and alleles are potentially valuable for the future varieties, and equally use that information in a very different manner. We're starting to get an understanding where we can use that knowledge and use that data to start to predict what the environment may look like, predict what kinds of varieties, the genomic composition of varieties will be needed for potential future production environments, and equally turn that round from the conservation perspective and try to start to pinpoint those areas where, due to climate change, due to shifts in cropping systems, a lot of that genetic variation that's currently in the fields may be lost, and to start to target and pinpoint those areas where collections may be required in a much shorter time frame than has been anticipated.
Great, thank you. From the conversation, would that lead one to believe that there might be opportunities to expand this partnership and bring in some additional partners and funders to expand the range of crops that could maybe also benefit from this particular approach? Would there anyone that wants to try to tackle that one?
I think in principle, yes, but it's not only expanding the crop. I mean, it is about expanding the crops. It's about expanding the reach. But I also think we need to think of really bringing in some external watchers to really look at this scientific experiment and this partnership experiment. So I actually think there's also room to bring in a bit of different thinking. So I think we can crowd in more resources in the project per se. And I think we need to bring in some capabilities that can observe this project as a model project. It's the first sprint. So what can we learn from this first sprint? It's a multi-crop endeavor. It is a multi-disciplinary partnership. So can we bring in, I don't know if they exist, but scientific anthropologists that can look at how this science community anthropologically, socially is coming together, and are we actually making, as a scientific society, progress towards a higher state of mind, like they call it. So it's that double plea. I think additional resources, additional crops, additional reach, additional partnerships for that. It is that external observation. And third, I think there's a lot of scope to bring in additional investment in then the outreach piece of this, which can be to the general public, but also the impact to farmers and farmers communities. And how do we measure that outreach and that impact?
Great, thank you, Bram. Anyone else care to comment on that? Oh, go ahead, Sarah.
I mean, there's certainly a strategic opportunity to make sure that this learning is translated into other very, very important species globally. In particular, those species where we know climate change is going to have a big impact, where we know there are limitations in the genetic diversity that's available for breeding right now. But we can't miss the next step. Yeah, we can develop as many new donor germplasm sources for drought, heat tolerant related breeding, but unless there is investment further downstream in that breeding system and in the national systems and the seed system, we're going to still be developing products that can't go anywhere. So yes, I would absolutely say we could do with additional investment to expand the range of species that we're looking at, to make sure we can really capitalize on the knowledge, tools and skills that are being developed now. But we need to make sure that there is a clearly defined, well-resourced pathway to make sure that that genetic variation is delivered to farmers. Yeah, because the last thing we want are more flasks on the gene bank shelf.
Great, thank you. Do we have time for one more question, or I think we're at the top of the hour, but there's maybe one that I'd like to try to get out there, and it's from Soraya Bertioli, and she says she's working with wild relative of peanut for over 20 years. We all agree that biodiversity is rapidly disappearing, and I wanted to address this one because, Eliane, I think you brought this up as an urgent need. Countries like Bolivia, that is one of the cradles of wild peanut and cannot transfer any germplasm to any country due to the plant treaty. In the last 3 years, over 250 wild peanut accessions recently collected were lost due to a lack of appropriate seed storage facilities. Because of the current legal systems, researchers were not able to send accessions that were sent due to any international seed for backup. And so many accessions were lost, and she capitalized the word forever. And so this is one example among many. So what can Crop Trust, CGIAR, Gates do to help this towards either more flexible rules of germplasm exchange, or to try to change the current treaties so we can deposit germplasm more freely and researchers can use them to ensure food security?
So one of the things I'd like to say is, you know, the beginning of her question is really around national systems and how do we strengthen national systems, because part of it is it starts there, is we need to have the stewardship necessary for local governments to be able to store what they have, and then identify what are the enabling and the resistors in the systems that may prevent easy transfer of accessions and to ensure that, you know, we're able to share. But preserving it locally is really urgent. And how do we strengthen that? How do we strengthen government awareness of the need to support this? Because at the end of the day, you know, international systems can't be doing it at all. We need local buy-in. We need local buy-in for biodiversity preservation. We need local buy-in for orphan crops because they're critical to sustainable diets with climate and the reduction of non-communicable disease. We need to make orphan crops sexy for diets, for people to want to have a diverse plate. And that's something in terms of the urgencies of how do we pull the system so that those accessions that are available are used. We really need a system where humanity understands the importance of preserving that biodiversity and having it on our plate. And we need governments to support that system locally. And of course, we need international support to do that. But we need local buy-in. And I think we have to work at all those levels together to get there. And so I appreciate that question. And it's a complex one because, you know, we've all talked about the innovation ecosystem and how when it's broken, we don't have flow. So it's the urgency of how do we get that done and how do we have the opportunities of COP27 and COP15 be places where we encourage financing and support of national agricultural systems to have that base locally.
That was a great answer, Eliane, and that was why I wanted to ask that question before we break up, because I think it's really an important question. This is a global challenge and a global issue, and it's going to take cooperation at the local level and at the continent level and at the globe and the country level. And I think that was a great question, great answer. I think that's a really good place for us to maybe end this conversation, although I think this is an important conversation, and I think it's great that there is COP, that we've got this Aim for Climate sprint. I think hopefully from the comments of this really distinguished panel, we've been able to really communicate that this is really a really good chance for cooperation and collaboration locally, globally, to really help try to solve some of these issues that are being created by climate change in our world. So thank you, especially join me in thanking all of the panelists, and thank you to all of you who participated and for the questions. Really appreciate it, and have a great weekend, everybody. Bye-bye.
Thank you, Jeff. Excellent moderation. Thank you all. Bye-bye.
Thank you, everyone.
Thank you. Bye.
Bye.
Bye-bye.